Hello students. In the last lecture, I discussed about what is instruction cycle, what is fetch cycle, what is execute cycle. In this lecture, I'll be discussing about machine cycle and T-states. So all these terms are required for better understanding of timing diagram of 8085 microprocessor. So what is machine cycle? The necessary steps that a microprocessor carries out to perform the operation of accessing either memory or input-output device constitute a machine cycle. In other words, the necessary steps carried out by microprocessor to perform either a fetch operation, a read operation, that is a memory read operation, a memory write operation, or input output read operation or input output write operation constitute a machine cycle. In a machine cycle, that is in one machine cycle, only one basic operation such as opcode fetch, memory read, memory write, or input output read or input output write is performed. That is, only one basic operation will be performed in a single machine cycle. So every time I'm saying the necessary steps carried out by microprocessor, so what are these necessary steps? So the necessary steps include to send memory or input output device a set of signals, that is like IO/M bar or ALE, RD bar or WR bar, etc. So these type of signals, they constitute the necessary steps. So when a microprocessor uses these type of signals to access either memory or input output device, that constitutes a machine cycle. Now an instruction cycle may consist of several machine cycles. The opcode of an instruction is fetched in the first machine cycle of an instruction cycle. For example, let's take an example of this instruction MVIB 05H. Or just let's take the example of MOVAB. Now this instruction, it is a single byte instruction having just the opcode which needs to be fetched from the memory by the microprocessor. So for implementing this instruction, as I've already told you in my earlier lecture also, that for implementing this operation we need 3 clock cycles for fetching the opcode from the memory by the microprocessor and 1 clock cycle for decoding the opcode and executing the instructions. So all total 4 clock cycles. So these 4 clock cycles are actually used for fetching the opcode and executing the instruction. So in general, all the single byte instructions will be needing, generally in most of the cases, all single byte instructions will be needing only 4 clock cycles for the execution of this instruction, and that 4 clock cycles is just for fetching the opcode and executing it. So this is also called, these 4 clock cycles will constitute a machine cycle for opcode fetch. So in a single byte instruction, for execution of a single byte instruction, we need only 1 machine cycle, and that machine cycle is for opcode fetch, and it will constitute of 4 clock cycles, and among those 4 clock cycles, 3 will be fetching the opcode from the memory and 1 for decoding and executing it. Again, I am repeating, for single byte instructions we need only 1 machine cycle, and that is for opcode fetch. So from here we can conclude that machine cycles can be of various types. As I've told you that in one machine cycle only one basic operation will be performed. So here what is the basic operation? It is the opcode fetch. So machine cycle are of various types. It can be opcode fetch machine cycle, it can be memory read machine cycle, it can be memory write machine cycle, or it can be input output read machine cycle, or it can be input output write machine cycle. So for single byte instructions we need one machine cycle, and that is opcode fetch machine cycle. So in 2 byte or 3 byte instructions like MVIB05H, it is a 2 byte instruction. So in 2 byte or in 3 byte instructions we need more than one machine cycles. So basically in all the instructions, whether it's 1 byte or 2 byte or 3 byte, the first machine cycle will be for opcode fetch, and it will be of 4 clock cycles. Generally it will be of 4 clock cycles, but there are exceptional case also where we need 6 clock cycles for opcode fetching. That I'll be discussing when I will be discussing the instruction set. I'll be discussing that in the later slides. So till now you just get this point, whether it is a single byte or 2 byte or 3 byte instruction. In all the byte instructions, in all single byte, 2 byte, or in all the instructions, the first machine cycle is used, that is for opcode fetch. That means the first machine cycle is the opcode fetch machine cycle. Now if it is a 2 byte instruction, then we might be needing memory read or memory write, or input output read or input output write, depending upon the type of the instruction. In 3 byte instructions there will be more machine cycles needed. So for example MVIB05H, so what is the operation of this instruction? The operation of this instruction is to store the immediate data 05, that is this 1 byte data, into the register B. And how this instruction gets stored in the memory? When we are storing the instruction in the memory, first the opcode of this instruction, that is 06H, will get stored in the memory location, and next the hexadecimal number whatever is mentioned with this instruction, that 1 byte data will get stored in the next memory location. So for execution of this instruction, what will happen? First machine cycle will be used for opcode fetch. So in first machine cycle opcode fetch will occur, which will constitute 3 clock cycles for fetch cycle and 1 clock cycle for decoding. So after decoding, the microprocessor will get to know that it has to store some data into the register B, but it has to get that data from the memory. So the next machine cycle will be used by the microprocessor to read or to get that data, that is 05H, from the memory. So the second machine cycle will be used for memory reading, that is getting the 05H data from the memory and then executing the instruction. So this whole instruction needs 2 machine cycles, one for opcode fetch and one for memory read. So the opcode fetch, generally the opcode fetch machine cycle constitutes of 4 clock cycles, and the memory read machine cycle constitutes of 3 clock cycles. Now, next term that I am going to discuss is T-state. What is T-state? T-state is T-state is one time period of frequency of microprocessor. Or you can say it is the subdivision of an operation performed in 1 clock cycle. For example, this is a machine cycle. This is machine cycle for opcode fetch. So these are the T-states. These are the T-states. 1 clock cycle will constitute 1 T-state. So basically our T-state is measured from falling edge of 1 clock cycle to the falling edge of next clock pulse. As you can see, a T-state is measured from falling edge of 1 clock cycle to the falling edge of the another clock cycle, and 1 clock cycle constitutes 1 T-state. Or you can say 1 time period constitute 1 T-state. Or in more simpler terms, you can say the necessary steps which are to be carried during this time period, during one time period or during one clock cycle, will constitute one T state. And what are those necessary steps? If it is for opcode fetch, it is for memory read or memory write or input output read or input output write. So whatever the necessary steps, so the subdivision of those necessary steps performed in one clock cycle is called T state. So next, coming to the point, timing diagram. So what is timing diagram? Timing diagram is the graphical representation of the necessary steps which are carried out by the microprocessor in a machine cycle. So this timing, so in the next lecture, I'll be discussing about the timing diagram for opcode fetch cycle, for memory read cycle, memory write cycle, input output read and input output write cycle. So I'm ending this class here. Thank you.